everyone. Welcome to this session of Alpha e-learning to make learning simple and more interesting. Today we shall discuss about basic proportionality theorem, another important content for the students of standard 10th. Basic proportionality theorem was introduced to the world of mathematics by one of the most famous Greek philosopher, mathematician and scientist Thales of Miletus. According to him, for any two equiangular triangles, the ratio of any two corresponding sides is equal, and based on this concept he proposed the basic proportionality theorem. Now before switching on to basic proportionality theorem, let us look into two important properties which will be utilized to prove the basic proportionality theorem. So the first property, the ratio of areas of two triangles with common or equal height is equal to the ratio of their corresponding bases. So we shall visualize this statement. Here is triangle ABC, top one is vertex A and the base is BC. So consider point D on base BC, that is between vertex B and C, and if you draw segment AD, then the segment divides the original triangle ABC into two smaller triangles, that is ABD and ADC. ABD is shown with green color shaded part and triangle ADC is with orange color shaded part. Now draw perpendicular AE, that is perpendicular to the base BC. Now this perpendicular AE, which is shown with red color strip, becomes a height for all the three triangles. That is, AE is perpendicular to base BD in triangle ABD, AE is perpendicular to base DC in triangle ADC, and AE is perpendicular to base BC in the original triangle ABC. So you should know the reason why AE becomes the perpendicular height for all the three triangles. So the reason is the perpendicular is drawn from common vertex A to the same baseline BC, and using uniqueness of perpendicularity, one and only one perpendicular can be drawn from a point outside the line to this particular line. So I will repeat the fact, one and only one perpendicular can be drawn from a point outside the line to the particular line. So just look at the board. Area of triangle ABD is equal to half into base is BD and height is AE for triangle ABD. Now for triangle ADC, half into base is DC and the corresponding height is AE. So area of triangle ABD upon area of triangle ADC equal to, substituting the values, half into BD into AE upon half into DC into AE. Half and half gets cancelled, AE and AE gets cancelled. So what remains is area of triangle ABD upon area of triangle ADC equal to BD upon DC. That is, BD is the base for triangle ABD, DC is the base for triangle ADC. Now in short, if A1, B1 and H1 is the area, base and corresponding height of the first triangle, A2, B2 and H2 is the area, base and corresponding height of the second triangle, then A1 upon A2 equal to B1 upon B2 if H1 equal to H2. Coming to the second property, triangles with common or equal bases and equal heights are equal in area. So we shall visualize this statement. I'll repeat the statement once again. Triangles with common or equal bases and equal heights are equal in area. So here this shows triangle ABC, that is top one is vertex A, here this is base BC, vertex B and vertex C, and the second triangle which is shown with orange color shaded part is triangle DBC. D is the top vertex and base BC. Now if you draw the perpendicular height for triangle ABC, AE is the perpendicular height, that is AE is perpendicular to base BC for triangle ABC. Similarly for triangle DBC, you have got DF perpendicular to base BC. Now these two triangles, that is triangle ABC and triangle DBC, lie between two parallel lines, and the perpendicular distance between the two parallel lines is always same. Therefore, AE is equal to DF, that is height of first triangle is equal to the height of second triangle. So just look at the board. Area of triangle ABC equal to half into BC into AE, that is half into base into height. Area of triangle DBC is half into BC into DF. DF is the height for the second triangle. Therefore, area of triangle ABC upon area of triangle DBC equal to half into BC into AE upon half into BC into DF. Therefore, area of triangle ABC upon area of triangle DBC equal to 1. Now, how you get 1 is half and half gets cancelled, BC and BC gets cancelled, AE is equal to DF, so that also gets cancelled, and then next cross multiplying you get area of triangle ABC equal to area of triangle DBC. So in short, A1 is equal to A2 if B1 equal to B2 and H1 equal to H2. So do remember the fact, triangles with common base and between same parallel lines are equal in area. So I'll repeat that. Triangles with common base and lying between same parallel lines are equal in area. Basic proportionality theorem is also known as Thales theorem. BPT states that if a line is drawn parallel to one side of a triangle and intersects the other two sides at two distinct points, then the line divides those two sides in proportion. So we shall visualize this statement. Here is triangle ABC, top vertex is A, vertex B and vertex C. Line L is parallel to side BC. Line L intersects side AB at point D, side AC at point E, such that points A, D and B are collinear points, A, E and C are collinear points. So what is to be proved is, these two sides AB and AC are divided in proportion. So here side AB is divided into two parts, AD and DB. Side AC is divided into two parts, AE and EC. So what is to be proved is, AD upon DB is equal to AE upon EC. And the construction for this, draw segment BE and segment CD. So all this is written on the board, given to prove and construction. Next we shall come to proof of BPT. So if you check the left hand side of to prove, you have got AD upon DB. Now AD is the side of triangle ADE and DB is the side of triangle BDE. So I shall show that. Now here this line is D, this vertex is A, D, E, and here you have got B, D, E. So ADE triangle is shown with green color shaded part and BDE triangle is shown with pink color shaded portion. So if I rotate this figure, it becomes in this form. So here you have got the common vertex E, this is vertex A, this is vertex D, and this is vertex B. So you have got the collinear points A, D and B. Now if I draw a perpendicular from the common vertex E to base AB, so this green color strip becomes the height. It becomes a common height for the two triangles. So using your first property, A1 upon A2 equal to B1 upon B2. So the base for triangle ADE is AD and base for triangle BDE is BD. So look at the first point on the board. Triangle ADE and triangle BDE have common vertex E. Therefore, area of triangle ADE upon area of triangle BDE equal to AD upon BD. We'll consider it as equation number 1, and the reason is A1 upon A2 equal to B1 upon B2 because those two triangles have common height. Coming to point number 2, the right hand side of what is to be proved is AE upon EC. Now AE and EC, AE becomes the side of triangle ADE and EC becomes the side of triangle CDE. So we shall consider those two triangles. So here you have got triangle ADE and triangle CDE. So AD is shown with green color shaded part and CDE triangle is shown with blue color shaded part. So if I tilt the figure, you get it like this, in this form. So now your points A, E and C are collinear points. A, E and C are collinear points and D becomes the common vertex for those two triangles. Now if I draw perpendicular from D to base AC, perpendicular from common vertex D to side AC. Now this height becomes the common height for those two triangles. So again using the property A1 upon A2 equal to B1 upon B2 because height is common. The base for triangle AED is AE and the base for triangle CED is CE. So just look at point number 2 on the board. Triangle ADE and triangle CDE have common vertex D. Therefore, area of triangle ADE upon area of triangle CDE equal to AE upon CE. Consider it as equation number 2. The reason is A1 upon A2 equal to B1 upon B2 since height is common. Now coming to point number 3, triangle BDE and triangle CDE. Now if I reverse this figure, these two triangles, that is this becomes vertex C, CED and this is BDE. Now these two triangles have common base DE. These two triangles have common base DE and these two triangles, that is BDE and triangle CDE, lies between two parallel lines, that is DE and BC, and hence the perpendicular height for these two triangles will be equal. So just look at the board. Triangle BDE and triangle CDE have common base DE and these two triangles lie between parallel lines DE and BC. Therefore, the triangles have equal height. So using next property, we'll get A1 equal to A2. That is area of triangle BDE equal to area of triangle CDE. We may consider it as equation number 3. Now point number 4, area of triangle ADE upon area of triangle BDE equal to the numerator part as it is, that is area of triangle ADE. Instead of area of triangle BDE, we can substitute area of triangle CDE. That is from equation 3. We have got both the areas equal. Now value for this part, that is the left hand side part, we have got it as AD upon BD from equation number 1. And value for this part, AD upon area of triangle ADE upon area of triangle CDE is nothing but AE upon CE, that is from equation 2. So we get AD upon BD equal to AE upon CE. The reason is from 1 and 2. Hence proved. Thank you for watching. Keep watching and rejoin us in our next session.